Many databases use disk to persist the data. The data is often encrypted or stored as a binary, meaning that you cannot interact with it directly. Let's say open the file, modify some lines, and see the underlying data has changed. But having the file system as a source of truth could be rewarding. For example, for my personal blog, I use GoHugo, where the articles are just markdown files in the Git repository, which is some sort of database. The articles have tags and authors, get version control for free, easy collaboration, but it's not a database. If the amount of files is huge, it will be hard to navigate or search or connect it to other sources, for example. So here you can see all my articles, they're just files in some folder. That's eventually synced to the Git repository. So is it possible to have a file system backed by the database? Yes, it is with TigerFS, which is a file system backed by the Postgres and a file system interface to Postgres. Every file is a real Postgres record. Directories are tables, and file contents are basically the columns. Multiple users can read and write the same files concurrently with full ACID guarantees. And so the file system becomes the API. And this is really cool for agentic world. Agents don't need fancy APIs or SDKs. They love the file system, ls, cut, and find and grab, and other pipeline Unix tools. And so TigerFS makes files transactional and concurrent by baking them with a real database. This is an open source project from the creators of TimescaleDB. I think the company is called Tiger Data. And so if you look at how it works under the hood, right? So we have the Unix tools like lscat and so forth. It works through mounting the directory. On macOS, it will use NFS. On Linux, it will use Fuse. Then it runs, or we need to run the TigerFS daemon locally, and then there is a Postgres backend. And it's very important to mention that it's not unidirectional, it's actually bidirectional, so the file system updates will go to the Postgres and vice versa. But we will get into that in a second. As the documentation says, it can be primarily used in two different ways. The first one would be where you have the files locally, you organize them into various directories, and then kind of TigerFS will push it into the Postgres database. And another way is maybe you already have the database somewhere, and you just mount it to the directory, and you can explore this database using the tools like lscat, or you can just open it in your editor. All right, let's see the TigerFS in action. I believe that one demo worth more than 1,000 words. So let's see the file-first approach. Similar to the blog, for example, I had with markdown files, but using the TigerFS backed by the Postgres database. All right, let's install the TigerFS first. By the way, I like the design of this website, but they could just add the copy button here. Anyway, interesting, it asked me to install the skills into the directory of my choice, so Claude or agents. I personally don't use Claude, I use agents, but I also don't need this skill, so I'll just hit skip for now. Also, I haven't looked at their code base yet, or maybe something I can do later, but it prints the Go version, so probably it was written in Go. That's kind of cool. Also, to test this out, you need Postgres server installed on the machine. You can use Docker or Brew. I have it already installed, so I won't do that. Now let's create the Postgres database for our block. So Postgres comes with the CLI create DB. So let's call our database Shiny block. So we'll create that. The next thing we should do is to mount this database to a local directory. As you remember, on macOS it will use the NFS for that, and the command line thing we will use is TigerFS mount. So we will do TigerFS mount the connection to our database. So again, it could be local database, could be remote database, and the absolute path to the local folder. As you can see, it actually doesn't say anything, doesn't print anything out. And to be honest, the first time I was actually surprised. I was not sure if it's actually doing something, but it's a daemon that's actually mounted the database to the folder. So we'll keep it running and we go to, let's say, different tab, or you can run it maybe with systemctl, whatever is your choice for running daemons. Let's explore this folder. It was actually empty before I ran the TigerFS mount command, but TigerFS created some internal folders. And the TigerFS works in the concept of so-called apps, which we need to initialize. These apps will become the tables in our database, and you could do it by kind of defining the list of features or the type of the content. So the most simple one would be Markdown, and you do it exactly to build, and then you name it. So let's do the table will be called post. So this second part could be anything. It will be the name of the table. For the block, something like post makes sense. I'll show you other options here, so you can enable the history and so forth, but the most simple would be this command. Now let's hit ls again. As you can see, the post folder has been created. So I didn't create it, it was created by this daemon. And now we can alter some blog posts. So we can do posts, let's say write some article, markdown. But actually before I write anything, let's just connect to our Postgres database. Let's connect to our database, what we call the shiny block. And maybe let's enable the advanced view and let's see if there are any tables. So let's say select everything. Oh, we can do /dt. TigerFS creates this schema for us. So it's not the public schema, it will be TigerFS. We can do like that, right? Yeah, so that's our table called posts. Now if you do select let's do all from TigerFS posts, right, we have 0 rows obviously. Now it's time to write our article. And for that, I'll just copy the beginning of the article I already had on my blog. This thing on the top, I'm not sure if you've seen it before, is something called front matter, I believe. It's the YAML that you put in front of your Markdown files. That's pretty much the same what Hugo already does. So if you use Go Hugo, it will be actually really simple to just do that. And then there is a body of which is like Markdown itself. So I'll just hit save here. And let's rerun our query. This is pretty cool, right? We have the proper record in our Postgres database. So the keys from this front matter became the columns in the database. So we have title, author, there is JSON headers, and there is a body itself. Now we have all the features of the Postgres to kind of work with our articles. And because it's kind of based on the NFS file system, we could do everything we want, right? We can just use cp commands, etc. So let's do, let's say article in the article 2. So we just copying the file, right? So we're just working with files. And then if we select, there are actually 2 articles now. Pretty cool, right? The same goes for removing something, right? Let's remove the second article and just immediately hit the select, and we will have only 1 article left. What's even cooler that we can open this article 1. There's an article, right? And because I mentioned that it's bidirectional, we can do some actions in the database. We can do update TigerFS posts. Let's say set body equal, let's say new. Right, so we hit this database update. I didn't do anything in the file, right? You see the new Vim just loaded the new content as it does when there are changes in the file system. Pretty cool, right? Obviously, we can also change the title, we can change the file name, even everything we would do in a database will be synced to the file system and vice versa. As I mentioned, TigerFS also supports the history. We can enable that. I think it's disabled by default. We can do very similar what we did with Markdown, but also comma history, and that will enable history on that table. So let's just do, and I think it's built what we had, posts. Sorry, I forgot this operator. Now the history should be enabled in the table. But actually what I read now is you need timescale DB running locally, I assume, or maybe use some cloud option, which I'm not sure I'm ready to do that just yet. I used timescale DB in the past, it's a quite nice tool. But yeah, maybe if you use it, you can check the .history folder. The use case I demonstrated is quite simple, though already helpful. And there obviously could be various use cases, for example, mounting your local folder to remote database and so forth. Though the author of this tool, Mike Friedman, says that the file systems backed by the database are really great for coding agents. I still have to try that, but I already see the appeal. As we all know, the coding agents, they love using file manipulation commands and tools such as cat, ls, and so forth. But if there are multiple agents working on the same file system or folder, they can interfere and they can make some damage to this file system. So having it backed by the database is actually quite good. Cool, and with that being said, thanks for watching. And let me know in the comments below if you see any other good use cases for TigerFS. Bye!